Today in this video we are going to see thermal engineering subject. Topic is gas turbine. Myself Rajkumar, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology. Gas turbine. In a gas turbine, the air is obtained from the atmosphere and compressed in an air compressor. The compressed air is then passed into the combustion chamber where it is heated consistent level. The hot air is then made to between the over the moving blade of the gas turbine which impart the rotation motion to the runner. During this process, the air gets expands and finally it is exhausted into the atmosphere. The major part of the power developed by the turbine is consumed for driving the compressor, which supplies the compressed air to the combustion chamber. The remaining power is utilized for doing some external work. This is the figure show open cycle gas turbine. It consists of the compressor, combustion fuel or combustion chamber and turbine, generator, motor coupled with the motor. So this is the schematic diagram of the open cycle gas turbine. We know the atmosphere pressure enter into the compressor. The main function of the compressor is to compress the air to high pressure, low pressure into high pressure. Air is sent to the combustion chamber. Combustion chamber, the fuel is burned and to produce the heat energy, the air is heated into the turbine to rotate in the turbine blade or rotates to mechanical. Here the heat energy is converted into mechanical work. The mechanical energy is connected to the generator to produce the power. Then in this type of gas turbine, liquid or gaseous fuel are used for power generation. The basic components are shown in the figure above. Initially, the atmospheric air is allowed to pass through the rotary compression, which is pressure and temperature is increased isentropically. Then it is compressed air is passed through the combustion chamber in which fuel is injected for combustion. After the combustion of the fuel is combustion chamber, then the heat is added under the constant pressure addition. The temperature of compressed air is further increased. Now high pressure temperature gas expands in the gas turbine, which is helpful. Gas turbine of or blade generally of reaction turbine. This gas turbine is directly connected to electric generator, produce electricity and finally exhausted to the atmosphere. This type of gas turbine works on open cycle because here working fluid is used only once. After single use, it is thrown into atmosphere. Here inlet and outlet both ends are open to atmosphere, hence term open cycle gas turbine. It is called continuous combustion gas turbine. Advantages: warm up time. Once the turbine is brought up to the related speed by the starting motor and the fuel is ignited, the gas turbine will be accelerated from cold start to full load without warm up time. Low weight and size. The weight is kilogram per kilowatt. Developed less fuel. Almost any hydrocarbon fuel from high octane gasoline to heavy diesel oil can be used in the combustion chamber. Open cycle plant occupies less space compared to closed cycle plant. The stipulation of the quick start and take up the load frequently are the point in favor of open cycle plant. When the plant is used as peak load plant, component or auxiliary refinement can usually be varied in open cycle gas turbine plant to improve the thermal efficiency and can give the most economical overall cost for the plant load factors and other operation condition increased. Disadvantage: the part load efficiency of the open cycle gas turbine plant decreases rapidly as the considerable percentage of power developed by the turbine is used for driving the compressor. The system is sensitive to the component efficiency, particularly that of compressor. The open cycle gas turbine plant is sensitive to change of atmospheric air temperature, pressure and humidity. The open cycle plant is high air rate compared to the closed cycle plant. Closed cycle gas plant. In the closed cycle gas plant, compressed air leaves the compressor and pass via the heat exchanger through the air heater. In the air heater are tubes through which the compressed air passes. The air is therefore further heated in the heater. This hot high pressure air then passes through the blade rings whilst passing over the rotor blade. The air is continuously expanding, its pressure energy being converted into kinetic energy which is stand is absorbed by the turbine motor. This is a closed cycle gas turbine. It consists of the compressor, and this is the compressed air into the heat exchanger and turbine, and this is a closed circle. Okay, the output is then again we have to give the input to the compressor, so that the name is the closed cycle gas turbine. This is the PV and TS diagram. PV pressure and volume diagram, and this is the second one is TS diagram, temperature with the entropy diagram. First of all, 1 to 2 work done on the system, 2 to 3 constant pressure heat addition process, 3 to 4 work done by the system, and 4 to 1 is the constant pressure heat rejection process. This is the PV and TS diagram of the open and gas turbine. Open and closed gas turbine. Advantages: use the high pressure throughout the cycle, which is useful for reduce the size of the plant. No outside air is used for compressing, so there is no problem of dust and dirty. Also, there is no need of filtration of incoming air. Any type of fuel can be used for combustion purpose. These are the advantages. Disadvantage: weight of the system is high compared to the cycle. Large amount of water is required for cooling in cooler. System should be airtight when working substances other than air is used.